Hello everyone, I am here to present my paper. The title is given here, SWTF, that is Sparse Weighted Temporal Fusion for Drone-Based Activity Recognition. These are the author for this paper, and I am Hari Mohan Pandey, who is presenting this paper. So first of all, I will give the context, that is the overview of conducting this research. So this research basically attempts to solve drone-based human activity recognition problem. As we know, human activity recognition is one of the most popular area of research, and therefore it has gained significant attention from the computer vision research community in the past few years. Human activity recognition played a vital role in several areas. Some of the pivotal role in the field like video surveillance, crowd behavior analysis, sport analysis, and human-computer interaction. What are the challenges with human activity recognition? So here in this slide, I have highlighted some of the challenges. We'll discuss the challenges one by one. So the challenges are complex poses, understanding different viewpoint, and the environmental scenario where the action is taking place. So to address these challenges, what we did in this paper, we proposed a novel sparse weighted temporal fusion model. What it does, it utilizes sparse images, sparse sampled video frame for obtaining global weighted temporal fusion outcome with significantly lesser computational time. So we are basically improving the quality of the outcome, and our system, our algorithm, our model takes less computational time to produce the final outcome. What are our contribution? So we developed a SWTF model, and it is basically divided in two parts. It has two components. You can see the first component is temporal significant network that sparsely samples a given set of frames, and the second component is weighted temporal fusion that incorporates a fusion of features map derived from optical flow with raw RGB images. And these two components are followed by a base network, which comprises a CNN, convolutional neural network module, along with fully connected layer that provide us with activity recognition. We have used what we incorporated in addition to the component and CNN. We have incorporated a region of interest for cropping the weighted temporal fusion module, and basically it helps us to it deals with extremely small size human subjects. It helps us to recognize human activity from high altitude of drone camera video, because drone is taking the camera from the top, so there will be high altitude, and then ROI will help us in managing such videos. And this module, that is SWTF module, can be used as a plugin module for existing deep CNN architecture for the optimization purpose, optimization of the final outcome. What we did to evaluate the performance of our model, we tested our model on benchmark data set. So as far as benchmark data set are concerned, we used 3 different data sets. So you can see the name of the data sets are here. So this is the first data set, second data set, and drone action was our third data set. The performance of our proposed model is presented here. So as far as accuracy is concerned, our model showed accuracy like 72.76% accuracy for this data set, 92.56% accuracy for the second data set, and 78.86 accuracy for the third dataset, that is drone action dataset. And when we compared this performance with state-of-the-art model, then we noted that our proposed model showed better performance over the existing state-of-the-art model on these three datasets. So this diagram shows the model, our proposed model. So you can see here, this is a sparsely sampled frames, ROI, region of interest cropping, then optical flow. So this is the fusion, OF1, OF2, optical flow, extraction, and then fused frames. So explanation is given here in the bottom in the form of caption. So show sparsely sampled frame, that is this. Then depicts how ROI works, then how optical flow extraction, and then finally fused frames. So this is the pipeline, SWTF pipeline. So you can see here temporal segment network, weighted temporal attention model, that is the second step. Third step is fused frames, and then this is base network. Here we used fully connected network, convolutional network. The detailed explanation about this SWTF model and SWTF pipeline can be seen here in the methodology section. So how what we did for data pre-processing, what we did for temporal segmentation, then weighted temporal fusion. So this is OFI is the combination of OF. If let me go back. So here you can see this is OF1. So we are extracting OF1 and OF2, OF3 like that, and then we are processing using connected networks. So this is the temporal attention. So the first row shows the outcome we received from drone action dataset on drone action dataset. Second row represents the outcome of mod 20 dataset, and third row represents the outcome of outcome by SWTF model for the third datasets of different activities and action performed by different user in the frame. Now dataset and results. So this is the summary of dataset used. So we used the 3 different datasets, and when we compared with existing models, our model shows 72.76 when we applied weighted temporal plus inception fusion V3 model. So this is a real-time video for the proposed real-time video of the proposed SWTF model. So let me run this. So here you can see carrying, calling, lying, standing, walking, carrying. So that's all. So you can see our model is capable to recognize human actions. So that's all from our side. And if anybody is interested to work on to work with our team, then you can drop us email, or if you are interested to know more about our research, then you can drop us email. We will try our best to respond to your queries as early as we can. Thank you very much. That's all.